Hello friends, this video on circles part 12 is brought to you by examfear.com. No more fear from exam. The diagonal of the cyclic quadrilaterals are diameter of the circle through the vertices of the quadrilateral. Prove that it is rectangle. It is given that there is a cyclic quadrilateral ABCD and the diagonals are actually passing through the center. That is their diameter. We have to prove that it is a rectangle. See, this is a diagonal, AC is a diagonal, AC will subtend an angle of 90 degree. If BD is a diagonal, BD will subtend an angle of 90 degree. If BD is a chord, BD will subtend an angle of 90 degree. If AC is again a chord, that is diameter, it will subtend an angle of 90 degree. All these angles are 90 degree, that means it is a rectangle. Okay. If the non-parallel side of a trapezium are equal, prove that it is cyclic. Non-parallel side, that is these two sides are equal. Okay, that is given. So we have to prove that it is cyclic. So let's put some number here. Let this be number 1, angle number 2, angle 3, and let these two 90 degree angle be angle 4, and this be angle 5. So we have to prove angle 1 plus angle 4 plus angle 3 is 180 degree, right? To make it cyclic, and let's give some number here, A, B, C, D, E, and F. This angle plus this whole angle is equal to 90 degree, that is 180 degree, that means it is cyclic. Okay. Now it is given that angle 2 is equal to angle 3. The sides are same. Okay. Now let's say in triangle ADE, angle 1 plus angle 2 plus angle 5 is what? 180 degree. Angles are property. So instead of angle 2 I can say angle 3. Angle 5 I can say angle 4 because angle 5 and 4 are same. And that is what we have to prove. Angle 1, 3, 4, 180 degree, angle 1, 3, 4, 180 degree. So I can say that angle 1 is what? Angle DAE. 3 plus 4, this whole angle, that is angle DCB. 180 degree. And that is the property of cyclic quadrilateral. That is the opposite angle, sum is 180 degree. Two circles intersect at the point B and C. Through B, two line segment ABD and PBQ are drawn to intersect the circle at ADPQ respectively. Prove that angle ACP, this angle, is equal to angle QCD. That is what we have to prove. Okay. So let's apply some property. So if you see arc DQ subtend this angle at C, the same arc subtend the same angle at B, right? So this angle will be equal to this angle. Correct? Now if you see arc AP subtend this angle at C, arc AP subtend this angle at B. So this angle will be equal to this angle. And we can see that these two angles are equal by vertical opposite angles. So thus all these angles are equal. So I can just note that. Let me put a number 1, 2, 3. Okay. Angle 2 is equal to angle 3. Angle by same arc DQ. Okay. Angle 3 is equal to angle 4. Vertical opposite angle. Angle 1 is equal to angle 4. Angle by arc AB. So we combine all these three equations. What do you get? What do you get? If you just combine all these equations, what do you get? Angle 1 is equal to angle 2. Right, see? And that's what we wanted to prove. So always put some numbers in the angles which will help you to prove the numericals pretty fast. Okay, let's try this question. So it says that the circle are drawn taking two sides of a triangle as a diameter. Prove that the point of intersection of these circles lie on the third side. Same thing, I think we have taken this, that we have to prove that this line is a straight line. And we have told that these two are diameter. So since AD and AC are diameter, this angle, that is ADB, is 90 degree and this angle ADC is 90 degree. So if you add these two, you get a straight line because you get 180 degree, that is a straight line. So we have done this question. ABC and ADC are two right triangles with common hypotenuse AC. So AC is the common hypotenuse, and with this common hypotenuse you get here, or let's say ABCD like this, AB, okay, this way. So ABC and ADC are two right triangles with a common hypotenuse AC. These two are right triangles. Since they are right triangles, it has to pass through center. AC has to be diameter. So we have to prove that angle CAD is equal to CBD. What is the angle CAD? CAD, this angle, is equal to angle CBD. CB. These two angles, the same we have to prove. Now if you see, just by looking you can say that, I mean these two angles are, see it is not given it is a part of circle, but it is given that this angle is 90 and this angle is 90, right? So angle D plus angle A is what? 90 plus 90, that is 180. That means ABCD is cyclic. If ABCD is cyclic, they are lying in a circle. They are lying in a circle, I can say that both this angle which we are talking about, DAC and DBC, are being subtended by the same chord CD. Therefore, angle CAD and angle CBD are equal. Why? Angle subtended by same chord. So the catch of this question is, it is given that there are two right triangles. That means we have to prove first that it is cyclic. Once we prove it is cyclic, then we can apply this logic. So we have to prove that the cyclic parallelogram is a rectangle. It's given that the cyclic parallelogram, and let this be 1, 2, 3, 4. Since it is cyclic, angle 1 plus angle 3 is what? 180 degree. Since it is cyclic. Since it is a parallelogram, angle 1 is equal to angle 3. Opposite sides of a parallelogram are equal. Compare these two equations, angle 1 plus angle 3, that is angle 1 plus angle 1 is equal to 180 degree, or angle 1 is equal to 90 degree. Similarly, angle 3 is also equal to 90 degree. Similarly, we can apply the same logic for angle 2 and angle 4. So we'll see that angle 2 and angle 4 will also be 90 degree. Thus, all the four angles, angle 1, angle 2, angle 3, angle 4 are 90 degree, and thus it is a rectangle. Let's do a quick recap. Circle is nothing but collection of all points in the plane which are equidistant from a fixed point, and that point is called center. Equal chords of the circle subtend equal angle at the center. If the angles subtended by two chords of a circle at the center are equal, then the chords are also equal. You have seen that. The perpendicular from the center of a circle to the chord will bisect the chord. And the converse is also true, that is the line drawn from the center to the circle, if it bisects the chord, then it is perpendicular to the chord. There is only one circle that we can draw from three non-collinear points. Equal chords of a circle are equidistant from the center, and the reverse is also true. Chords equidistant from the center are equal. If two arcs of the circle are congruent, then their corresponding chords are equal, and converse is also true, that is if the two chords are equal, then the corresponding minor arc and the major arc, they are also congruent. Congruent arc of a circle subtends equal angle at the center. Angle subtended by an arc at the center is double the angle subtended by the same arc at any other point on the circle. Angle in the same segment of the circle are equal. Angles in the semicircle is right triangle. If a line joining two points subtends equal angle at two other points lying on the same side of the containing line segment, then all these 4 points lie in a circle. The sum of either pair of opposite angles of a cyclic quadrilateral is 180 degrees, not 1800, is 180 degree. The pair of opposite angles of a quadrilateral is 180 degree, then it is cyclic. It's all converse. These two are converse, right? So a lot of things, if you see, they are converse of each other. This is also converse. This is also converse. And this is also converse of each other. Yeah. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.